everyone! Our topic for today in Science 8 Quarter 1 Week 1 is about 3 laws of motion. In here, we will learn the concept to investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. What are the lesson objectives? The lesson objectives are: number 1. Describe how external forces affect object at rest and in motion. Number 2. Explain how the net force acting in an object affects its acceleration. Number 3. Compare interacting forces in terms of magnitude and direction. First law of motion, law of inertia. Here are the example of motion: displacement, distance, velocity, acceleration, speed, and time. Force is defined as the push or pull of an object with a specific magnitude and direction. The push or pull on an object can vary considerably in either magnitude or direction. The man's body has inertia, and so as force is needed to change its velocity. The man's body moves backward as the bus moves forward. Inertia. What is inertia? Inertia is a body at rest remains at rest, or if in motion remains in motion at constant velocity unless acted on by a net external force. A more massive object which have more inertia is more difficult to move from rest, slow down, speed up, or change its direction. Second law of motion, law of acceleration. Study the figure shown. This shows acceleration of a large mass of an object. The moving truck accelerates at speed lower than smaller objects with smaller mass. Newton's second law pertains to the behavior of objects if the forces are not balanced or if the external net force is not zero. In the presence of a net force, the object will accelerate. Acceleration. What is acceleration? The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the object and the mass of the object, so the acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the net force increases, so the object acceleration will also increase. On this figure, which do you think has greater acceleration? Is it the car or the school bus? If your answer is car, yes, you are correct. The answer is car. The car, which has smaller mass, will have greater acceleration as compared with the school bus. Force is measured by multiplying the mass of an object to its acceleration. The formula is written as F is equal to mass times acceleration, where F is force, M is mass, and A is acceleration. Suppose a grocery cart has a mass of 0.45 kilograms is pushed with a force of 90 newtons. What will be the acceleration of the grocery cart? Following the Gressa method. Given mass is 0.45 kilograms, force is 90 Newton. Required acceleration. Equation. Acceleration is equal to force divided by mass. Solution. Acceleration is equal to 90 Newton or kilogram meter per second squared over 0.45 kilograms. Answer. Acceleration is equal to 200 meters per second squared. Third law of motion. Law of interaction. Newton's third law of motion deals with the reaction of a body when a force acts on it. Let a body A exerts a force on another body B. Body B will react against this force and exerts a force on body A. The force exerted by body A on body B is the action force, whereas the force exerted by body A on body B is called the reaction force. Newton's third law states that to every action, there is always an equal but opposite reaction. According to this law, action is always accompanied by a reaction force and the two forces must always be equal and opposite. Note that action and reaction forces act on different bodies. Here are some of the situations that deals from practically in understanding third law of motion. 1. Pushing a car. When making a push on a car, a force is exerted in a car whose reaction will push us directly with the same force in opposite direction. Hitting a ball. We exert an amount of force against the ball with the bat, which in action exerts same force on the wood. This is why the bat can break while the ball is thrown. Inflating a balloon. The air inside the balloon rushes down and the ball moves upward. In this situation, the action is by the balloon that pushes the air out when setting free. The reaction is the movement of the balloon that moves upward. And that would be all in Science 8 Quarter 1 Week 1 about 3 laws of motion. Thank you for watching. Until next time, goodbye! Click here to watch my recent video and click here to watch my previous video. And also subscribe!